Welcome back. Let's finish up section 2.1. We've just been looking at some special angles. So we have 30, 60, 90 triangles, and we've looked at the sine, cosine, and tangent of 30 degree angles and 60 degree angles. For 45 triangles, so isosceles right triangles, we saw that sine of 45 and cosine of 45 are actually the same number, and the tangent is 1. And these are very, very, very useful things to know and to memorize. So let's make ourselves a big table of this. So the sine of a 30 degree angle, I find that it's easiest to remember this one. So this is just one that I would want to have memorized. And we can start filling in the table, sort of working from this one, and maybe this first column. So the sine of a 45 degree angle is going to be the square root of 2 over 2. And sines and cosines are co-functions. So the sine of a 30 degree angle is the same as the cosine of a 60 degree angle. Also, the sine of a 45 degree angle is going to be the same as the cosine of a 45 degree angle. The sine of a 30 degree angle, the cosine of a 30 degree angle as well is going to be the square root of 3 over 2. And again, this is maybe one that I just remember. But then, if the cosine of a 30 degree angle will be the same as the sine of a 60 degree angle. And then tangent, we saw one identity last time. That was the tangent of an angle is going to be the same as the sine of that angle divided by the cosine of that angle, which makes, so once you know the sine and the cosine, the tangent is pretty easy. Sine divided by cosine, so it's going to be 1 divided by the square root of 3, but we'll probably rationalize the denominator, so you get the square root of 3 over 3. Square root of 2, so these two numbers are going to be the same, so the tangent is just going to be 1. And in this guy, we've got the square root of 3 over 2 divided by 1 over 2. The halves cancel, and we'll just get the square root of 3. Cosecant is going to be 1 over sine, so we can just take the reciprocals of these guys. So reciprocal of 1/2 is 2. Reciprocal of root 2 over 2 is going to be square root of 2, and the reciprocal of square root of 3 over 2 will be 2 root 3 over 3. And then the secant is going to be 1 over cosine, but also secant and cosecant are co-functions. So the cosecant of a 30 degree angle is going to be the secant of a 60 degree angle, because they are co-functions, and 30 and 60 are complementary. So then the same for secant of a 30 degree angle is going to be the same as the cosecant of a 60 degree angle. Also, 45 and 45 are complementary angles, so secant and cosecant are going to be the same. And then cotangent and tangent, these tangent and cotangent are both complementary, and tangent is going to be the reciprocal of cotangent. So there's lots of relationships between the tangent and cotangent. So this will be the square root of 3, 1, and root 3 over 3. Again, because these are just going to be the reciprocals, but also the cotangent of a 30 degree angle is going to be the tangent of a 60 degree angle, because these are co-functions and they're complementary angles. So there's lots of relationships going on here. 30, 40, 30 degree angles and 60 degree angles are highly related, and 45 is its own complement. So there's lots of nice things going on. This is a table that will be important for you to be able to work out. If I were to ask you for the sine of a 30 degree angle, the tangent of a 45 degree angle, you should be able to essentially know or be able to work those out by yourselves. So let's apply these. So here I've got a lot of lines. We'll just pretend that they're straight. So let's go through this. We've got sort of a triangle down here. I have a right angle and a 30-degree angle with theta in the other corner. This hypotenuse of this right triangle is the hypotenuse of this right triangle. And I've said that, oh, this angle and this angle are exactly the same. And we've got this right angle up here. And then I've labeled this side as being length 5. This is A, B, C, and D. So the question is, what are A, B, C, D, theta, and beta, this B? Well, first of all, this triangle here has a 30-degree angle, a 90-degree angle, so what's left has to be the 60-degree angle. And again, we can work this out. The 30-degree angle up here plus theta plus the 90-degree angle has to add up to 180, because that's the three sides. The three angles have to add up to 180 in the triangle. And if you solve this for theta, we will get 60 degrees. Cool. Over here, we have two angles that are the same. So this is going to be an isosceles right triangle. So we know that's a 45-45 triangle, 45-45-90 triangle, but we can still work it out. So beta plus a 90-degree angle should be 180 degrees. So beta plus beta, the last two beta, plus 90 should be 180. We subtract 90 from both sides, divide by 2, beta is just going to be a 45-degree angle. So we know theta and we know beta. Cool. So now we should start figuring out what are A, B, C, and D. So let's start with B here. So I want to relate B to the other sides of this triangle and the angles in this triangle. So for instance, if I'm looking at 30 degrees, and I'm looking at B here, B is the hypotenuse. So with B, I want to find a trig function that's going to relate the hypotenuse to a number that I know. Let's say 5. 5 is on the opposite side of 30 degrees. So I want the trig function that's going to relate the opposite side to the hypotenuse. This is the sine. So the sine of a 30-degree angle, if we come back up, sine of a 30-degree angle should be 1/2. Oops, I don't want to scroll. Oops, I don't want to scroll that far. Sine of a 30-degree angle is 1/2. But the sine of the 30-degree angle in this triangle is going to be 5, which is the opposite, divided by B. Again, 5 is opposite the 30-degree angle, B is the hypotenuse, and opposite over hypotenuse, that is the sine of the angle. So 1/2 is 5 divided by B. We can cross multiply to get B is 10. Cool. So this side length is going to be 10. Next, I want to figure out what A is. And again, A here, I can use this 30-degree angle, and I want to relate A to something that has that we already know. So for instance, I could use the cosine of a 30-degree angle. Why could I use the cosine of a 30-degree angle? Well, the cosine is going to be the adjacent over the hypotenuse. So the cosine of a 30-degree angle, we saw before, is going to be equal to cosine of a 30-degree angle is going to be √3/2. But we know that it's going to be the adjacent divided by the hypotenuse. So this is going to be the adjacent, which was A, in this instance, divided by the hypotenuse, which is B, and that's 10. So what I can do is I can multiply both sides by 10 to see that a is simply going to be 5 root 3. So far, so good. We've just used our 30-degree angle to relate the opposite side to the hypotenuse, and then we can relate the adjacent to the hypotenuse. So now that we know the hypotenuse of this triangle, we should be able to figure out C and D. So for instance, let me fill this in really quick. So B we said was going to be 10. So for instance, if I want to relate C to 10, and I'm up here with this angle, this is going to be the adjacent side to this angle. So if I want to relate the adjacent and the hypotenuse, I want to use the cosine. So let me do this over here. The cosine of beta, which is 45, is going to be the adjacent divided by the hypotenuse. But we also know that the cosine of a 45 degree angle is root 2 over 2. So cosine is going to be root 2 divided by 2. And that's going to be the same thing as adjacent divided by hypotenuse. And again, if I multiply both of these by 10, we'll see that C is going to be 5 root 2. And then the last piece of information, well, what is D? Well, this is an isosceles right triangle. Because both of these angles are the same, that means that C and D are also the same length. So D we get for free. We don't have to do any computation. We know exactly what it is. So this is just using sines and cosines of these special angles. We know what all these values are, so we can plug them in here and use them. So for instance, when I wanted to figure out what B was, it happened to be 10. I used the sine of a 30-degree angle, because that's going to be opposite, which was 5, divided by B, the hypotenuse. But I knew that sine of a 30-degree angle was 1/2. So this knowledge is very, very helpful. 45-degree angles, 60 and 30-degree angles show up a lot. So it's very good to have all these values in the back of your head.